Carbon is a fascinating element. It's in all living things. It also forms some incredible materials. We call these materials allotropes. Allotropes are different forms of the same element. They have different structures. This gives them different properties. Think about coal and diamond. Both are carbon, but they look and behave completely differently. In this essay, we will delve into 3 carbon allotropes: graphite, diamond, and C60 fullerene. Carbon has the atomic number 6. This means each carbon atom has 6 protons in its nucleus. Carbon also normally has 6 electrons. These orbit the nucleus in shells. The arrangement of these electrons, especially in the outermost shell, dictates how carbon bonds with itself or other elements, leading to a wide array of compounds, including the allotropes we'll be exploring. Graphite is a soft, slippery, grey material. It is used in pencils and lubricants. Its structure is the key to understanding its properties. Graphite consists of layers of carbon atoms. The atoms within each layer are tightly bonded in a hexagonal pattern. However, the forces between the layers are weak. These weak forces allow the layers to slide past each other easily. This is what makes graphite slippery. It also explains why it is used as a dry lubricant. The layered structure also affects graphite's electrical conductivity. The delocalized electrons within each layer can move freely, allowing graphite to conduct electricity. Diamond is very different from graphite. It is the hardest known natural material. Diamonds are used in jewelry and cutting tools. The structure of diamond explains its hardness. In diamond, each carbon atom is bonded to 4 other carbon atoms in a tetrahedral arrangement. This forms a giant covalent structure. All the bonds in diamond are strong covalent bonds. A lot of energy is needed to break these bonds. This is why diamond is so hard and has a very high melting point. It's also why it doesn't conduct electricity. There are no free electrons to carry charge. C60 fullerene is a relatively new allotrope of carbon. It was discovered in 1985. C60 fullerene consists of molecules containing 60 carbon atoms. These atoms are arranged in a spherical shape. The shape resembles a football. C60 fullerene has some interesting properties. It can act as a superconductor at low temperatures. It can also trap other molecules within its cage-like structure. This makes it useful for drug delivery. C60 fullerene is also being investigated for use in solar cells and catalysts. C60 fullerene is not as strong as diamond. This is because the bonds between the carbon atoms are not as strong. It is also not as good a conductor as graphite. However, it does conduct electricity better than diamond. This is because the electrons in C60 fullerene are more delocalized than in diamond. Ca60 fullerene has a lower melting and boiling point compared to graphite and diamond. This is due to the weaker intermolecular forces between the C60 molecules, which require less energy to overcome. In conclusion, carbon's ability to form these vastly different materials highlights the importance of structure-property relationships in chemistry.